you doing?
I have a question.
Oh,
I
yeah.
missed last week video session. Do you have a recording?
Oh, yes, I just posted it like yesterday.
I
So
see.
it's in the other module. So yeah.
Thank you.
Mhm. I saw you did your interview and that you did really great.
Thank you so much.
Yeah, you did really awesome. Like, you know, it's super good.
Uh,
Like,
so I have another question related to interview. Do
mhm.
you have a really good source how to learn space complexity?
Sorry, could you say that again?
Do you have a source where we can learn space complexity?
Um, Space complexity. Oh, I don't think you had like an independent score on space complexity. Um, I think they just had like comments around revisit space and time complexity. Like it's like a checkbox. So, but yeah, I don't think that they didn't have like an independent score for that.
Yes, I know, but I want to learn it a little bit more.
Oh, you want to revisit space
Yes, yes.
complexity? Yeah. Space complexity is a it's usually expressed similarly to the like big O notation, like people say it in the big O notation kind of way, but it's really about multiples of n. So, it's really about figuring out like how much extra space. Not so much about like, am I using another variable or anything like that. It's mostly about like if you've got an array or something, um, like are you duplicating that array? Are you doubling that array? Are you creating a bunch of subarrays? That kind of thing.
Okay.
So yeah, that's what it's mostly about. That big O, let's see, big O cheat sheet. I think it might be back up. Uh, yeah, let's see. Space complexity. Yeah, here's like a cheat sheet. Um, and yeah, I'll drop it in chat. Just like another, oh no, didn't copy and paste it.
Thank you. Yes.
Uh-huh,
Thank you so much.
for sure. So you might have noticed that my camera looks like way different. I just switched from my like MacBook to a Surface, and it's like the first time I've been on Windows in like 8 years. So you might notice me struggling a little bit with my keyboard shortcuts, just so everyone knows. I think it's about 6:03, so I'm gonna go ahead and get started. Everybody ready for that? Let's see who we got. 1, 2, 3, 4. Yeah, we got 6. All right, cool. Okay, so let's get started. First of all, yeah, everyone can hear me, I think, because I've been talking. Everyone can see me. Everything looks a little weird on this computer, so getting used to it. Okay, so what we're going to talk about this time is Module 7, the Stacks module, and interview techniques. So the big thing that I wanted to talk to y'all about this time was non-technical technical interview questions. What do I mean by that? Well, a couple of things. One, I mean behavioral interview questions where you're supposed to discuss a technical thing. And the other is there's these puzzle questions. You've probably heard of them. They're like brain teasers. Google kind of started doing them, and they're about uncovering how you think. And so I'm going to go over kind of some of those before we get started on the solution. So let's talk about that. So you may have gotten stuff like this, like tell me about your proudest technical achievement, or things like, sorry, let me quit Slack. Yeah, there we go. Anyway, tell me about your hardest bug you've ever fixed, what made it difficult, how you solved it, or things like, a time when you had to learn something entirely new. So these are not super trick questions, kind of like those other ones were. With your proudest technical achievement, the more you owned about the project, the better. The more actual coding that you did, um, the better this is going to sound. So if you, like, for instance, did an internship somewhere and it was a very technically advanced project, but what you did was something not super technically advanced, probably that's not your best example. Your best example is going to be something that you can talk about for a few minutes, or answer follow-up questions. The biggest thing that interviewers want to see is for you to get in detail about like what it is that you've actually done, and they want to see how much you were capable of owning, and how much you were actually responsible for doing. As a recruiter, it's very hard to tell exactly, especially with people early in their career, what they have actually been responsible for. A lot of times we see like group work and things like that on their GitHub, and we're like, okay, but which parts did you code? And it's actually a very tiny part that they coded. So talk about your proudest technical achievement where you own the most. Same thing with hardest bug you've ever fixed, something that you actually were able to fix and diagnose. Um, Try to make it about something that is really tricky, like an intermittent issue, something that has to do with distributed systems, or something where normal debugging practices, failed you, or at least the first level of normal debugging practices. And you either had to rely on something like print debugging on a large system where you don't usually do print debugging, or something like that. And then tell me about a time where you had to learn something entirely new. Growth mindset, we've talked about it a little bit, and it's one of the most important things that employers are screening for today. And so getting this question, you want to answer with something complex that you learned in a short amount of time, or a time where you maybe, like, if you worked in one language and you very quickly picked up another language, things like that. What they want to see is how fast can you learn? How eager are you to learn? Things like that. And so these are your chances to really show that. And then these other problems that are like puzzles. So I've seen a lot of these in interviews. Some companies have largely abandoned them. I think Google doesn't really do these anymore, but you still see companies doing these all the time. So let's think about this problem. And what I want to do to start us off today is jump into breakout rooms for just 15 minutes, and then we're going to come back, and we're going to talk out this problem. So this problem is meant to approximate a computer science problem, but remove all of the syntax and all of the typical like trappings of computers. And so you have two wooden boxes and a tower that's 100 floors tall, and you need to find the lowest floor window that you can throw the boxes out that will break the boxes. And you only have two. You want to minimize trips up the tower. That's, about efficiency. And you want to do it in as few trips as possible. And you don't get bonus boxes. With these questions, don't try to find a way around finding the answer. That will appear negatively on you in an interview. So if they state a question like, you have two wooden boxes and you've got a tower and you got to find the lowest one, don't give a smart ass answer like, well, I just go to the top one and throw them both off, and that would pretty much solve it. They're not looking to solve the problem in a critical, like, real world scenario. What they're looking is, can you think computationally in situations that are not explicitly computational? So what I want to do is just really quickly break out into breakout rooms of 3, and then I'm going to jump back and forth. And I want you to solve this problem. See if you can get to a solution. So I'm going to do this. I'm going to leave it up. And then I'm going to break you out into breakout rooms. Into 2 rooms. Cool. And then we're going to come back in like 10 to 15 minutes. It's not going to be a super long time. right, so let's discuss it. So which group feels like they found a really great solution that they want to talk about? Nobody? I'm just gonna pick somebody. All right. Aaron, how about you describe your approach?
Well, at first we just thought of the brute force solution, which would just be going up by one floor until you eventually find the lowest one. And from there, we went with going up by 2 floors each time, since we have 2 boxes to try, right? So like if the first one breaks, we can check the previous one. And if that one breaks, that's the lowest one. Otherwise, we know the first one where it broke, that's the floor. But then another way to do it would be to go by a bigger number of steps. So like, for example, let's say that the lowest floor where the box would break would be floor 24. So then we kind of picked an arbitrary number. Since it's 100 floors, we went like, okay, we're going to go up by 10 floors each time. And so we would start with the first floor, we'd throw the box, it wouldn't break. So then we go up to the 10th floor, we'd throw the box, it wouldn't break. Then the 20th, same thing, it wouldn't break. Then the 30th, that's where the first box would break. So at that point, we would know that the lowest floor where the box breaks is between 20 and 30. So from there, we'd start with the lowest possible floor we know it doesn't break, which would be 21. And we'd try that with the second box. It wouldn't break. Then 22, it wouldn't break. 23, it wouldn't break. 24, that's where the second box would break. And we know for a fact at that point that that would be the lowest floor where the box would break. So basically, you would go by a specific number of steps, mainly to be able to pick out a smaller range. And then once you get that range, you would do it incrementally until you know which one's the lowest floor.
Awesome. So this is known as the divide and conquer method, and it's pretty good for any kind of search. It's not binary search because you don't have enough checks. You have a limited number of like actual checks you can do. So yeah, it's basically you have to optimize for the number of attempts and then the number of like successful like signals that you're capable of getting back. So this is a great way to do it. Can anyone think of a way that might slightly improve it? It's not going to be like a crazy, pivot to a lot better, but can anyone think of anything? Just give you a few seconds to think through it.
To improve it, I'm assuming that there's kind of like a particular way to figure out what would be the ideal number of attempts. I'm not sure how you would go on about doing that, but I'm assuming rather than just randomly picking like 17 steps each time, right?
Mm-hmm. Yeah, so if you think about the tower, once you eliminate the first 10 steps by checking 10, you're really dealing with a 90 floor tower. And so you have to ask yourself, would I take 10 steps in a 90 floor tower, or how many steps would I take? And then once you take another number of steps, let's say 9, you're looking at an 81 floor tower. And then, so let's say, you divide that. Basically, the idea is that you kind of divide the tower up by a certain increment. And that increment gets smaller each time because basically you're kind of eliminating parts of the tower. So the size of your, remaining number to check gets smaller over time. It's very similar to how the binary search algorithm works, how, that window kind of gets smaller and you find the middle each time. Only instead of finding the middle, you're trying to find kind of what's like a tenth of it. And so the idea of doing 10 is great. But one of the ways that you can approach this type of problem is by maybe breaking it down into a smaller problem. Like, what would you do if it was a 10-story tower? What would you do if it was a 50-story tower? And that approach can kind of lead you there, lead you to the interval picking sort of function. But that's like the only like super like improvement that you could do there. And if you came up with the approach that you stated, Aaron, then that would have been like, you passed, you did it, you figured it out. Because it's, yeah, I mean, if you think about like how many steps would it take to identify the 99th floor as the lowest floor? 19. Or the 100th floor, that'd be only 10. But it would be, like 19 tries is like the max that you would get up to. So you found a pretty good solution, honestly. I believe that is, it's a little bit over log, but it's sublinear. So that's, pretty good. So yeah, if you run into a problem like this, remember to try to think of it not like a real world problem. Like, don't worry that maybe it's not reasonable to think that the box would break on the first floor or the 30th floor, or that the boxes will never break. Try not to find too many holes. And if you do, like if a bunch of holes spring to mind, like in the question, ask them as questions. Is it likely that the boxes are this? Do we know anything about the like strength of the boxes, or is this not the goal of the question? Ask questions about what details are super important to this question, and that'll help you narrow down what's a red herring and what isn't. So yeah. I've gotten this question before a couple of different times with a few different variations, and I haven't gotten it in a very long time though. So it's really meant to figure out how you think without worrying about how you code. Yeah. So now I'm going to talk about stacks, basically. I'm going to talk about how do we use stacks here to solve this particular problem. So it's one of the practice problems from module 7 is daily temperatures. So let's kind of go over this one. So when you're thinking about, I mean, normally I wouldn't just tell you, hey, solve this with a stack, but it's the stacks module, so I don't feel like I can, hide that from you. So when you're thinking about whether or not to use a stack, one of the best ways to like identify a good place to use a stack is anytime where you might want to be using multiple indices to keep track of something, not like 2 pointers that you like progressively narrow, but multiple indices. And so here's kind of an example of a good time to use that. So given a list of daily temperatures, that's just your input here, return a list such that for each day in the input, so our output's going to be the same size as our input, it tells you how many days you would have to wait until a warmer temperature. If there is no future day for which this is possible, put 0 instead. Okay, so all the temperatures will be between 30 and 100. So if we run into 100, we know that it's not gonna be hotter than that. So here's an example, and here's kind of how I think about going through this. So 73, we can kind of see that that's 1 because 74, that's how many days you would have to wait before it's warmer. So for 73, we'd put in 1, and that's because the number right after it is larger. And for 74, we'd put 1 because the number right after it is larger. For 75, however, the next number is not larger. And in fact, it's several days before we do get a larger number. So if you're doing something like this, you know, your first instinct might be, I need 2 for loops because I need to loop over it again. I need to loop over my entire list and compare, you know, maybe starting at this point or starting at this point and compare all the numbers after it, right? But this is where you want to use a stack because keeping track of these temperatures will help you to see how many there are before the day is hotter. And because there's information here like 71, you're going to have to wait 2 days before it's warmer than 71. That helps us to kind of maintain like an arbitrary number of pointers throughout this list. So that's kind of how we're going to use this stack. So I'm going to talk out first the pseudocode and talk about like how does that work. So because our output for each day in the input, a list such that for each day in the input tells you how many days you would have to wait until a warmer temperature. So we know that we're going to need a list, create a list the same size as daily temps. So that's like a minimum. There's no way around that because we need to return that. And so, you know, for space complexity, don't worry. And then what we'll need is a stack. Create a stack. Okay. Now, what you're going to want to do is we care about the indices of this. So we care that 73 is the 0th index and 74 is the first index and 75 is the second index. So loop over the loop over daily temps by index. All right. And then what we want to do is we want to see while there's something in the stack and our current temperature is, it's less than the top of the stack. Yeah, less than the top of stack. At that point, what you want to do, this is a hotter day, right? So we're going to loop over each one and then basically check to see whether or not the last temperature that we checked is hotter, right? And so that's going to be checking the top of the stack. Normally, before we had thought about to use stacks, we might have done something like check the last index, right? But it's not always the last index that you care about. It's really more like the you know, last hotter index, right? So then at this point, if you found a hotter day, you want to pop the current element off the stack and call it something like, you know, last hot day. So like pop last object. And then what you want to do is mark the index. So when we loop over daily temps, what we want to do is we want to like add something to the output, right, for each one of these numbers. And so last temp, there we go. And then, so what you want to do is mark the index in the answer array as having like the same index as the hotter day, or like, yeah, sorry, mark the same index in the list as the popped element as the offset between this index and the last hot day. sorry, there, I'll put that on the same thing. And then what we want to do is for every time you hit a number, you're going to want to add it to the stack. And then at the end, you can return that array. And okay, sorry, someone's talking in the hall and I'm losing my train of thought. Let's see, lost my train of thought, oh no. All right, where was I? Let's see, we're creating a list, looping over the indices. Yeah, I wrote out all of that stuff. Okay, and then, all right, so at this point, now I'm going to translate, and even though I lost my train of thought, I've made myself a plan, so it's okay, so that I can solve it. So I'm just going to go through and say, like, you know, let's see, the output equals a list that is, it's going to be all zeros times the length of daily temps. It's got to be the same size. And then we need to create a stack. Now, I haven't talked about the implementations of stacks. If you have taken a data structures and algorithms class, don't worry that we're not using a real stack. We're just using a list. In Python, lists are meant to be very flexible, and so they're like usable as stacks because the last element's always easy to get to, or the first element as well. So basically a list functions as a stack, even though it's not the precise abstract data structure that is known as a stack. If you haven't taken a data structures and algorithms class, just think of a list as a stack. Okay, let's see. Now, we're going to create a stack. That's a list here. Okay. And then we need to loop over daily temps by index. So for index in length of range of daily temps. And then I'm going to just provision a variable here so that I don't lose it. Let's call it temp equals daily temps at index. Just kind of so that I have, you know, an easy variable rather than dealing with it. Okay, so now anytime that you're dealing with a stack, this part is important. It's usually a while loop, because what you're doing is you're making sure that there's something in the stack, and then you're kind of going backwards through the stack to make sure of the item's relevance in the stack. This is a common pattern with stacks where you have a for loop, and then you have a while loop right under it where you kind of go back through the stack, right, to make sure. This is kind of like how you achieve reverse search. So while length of stack is greater than 0 and temp is less than, is less than the top of the stack. So stack at -1. Okay, so this is a hotter day. So what we need to do is last temp that was hotter than it. So last, last temp. And basically, as soon as we find a day that's hotter, what we want to do, so these elements are, let's say that we've got 71, 69, and 72 in the stack. As soon as we hit 76, what we want to do is go back to 72 and say that there's one day that they have to wait. Or for instance, with, let's see, let's go with, with 75, it'll be a lot of days, right? And so you want to go pretty far back. And so you'll be adding like 71 and 69 and 72 and then 76. You'll get to there and you'll want to have to go back and mark 75 as the difference between the index here and the index here. So that's what I mean by these next two lines. So last hot temp, let's say last hot temp is stack dot. Okay, sorry, let me just close Slack. Okay, cool. Well, this isn't really the last hot temperature. It's really the index of the last hot temp. Yeah. Okay, that makes me feel better. So then at this point, we want to mark the same index in the list as, let's see, mark the same index in the list as the popped element as the offset between this index and the last hot day. Okay, so the output at index, right? This is the number we're checking, is, sorry, I need to add my index to the stack so that I can kind of get that, so that I can mentally picture it. So we'll add stack, we'll add the index, sorry, append index. So every index goes into the stack, but we're going to reset indices as we move on as the index of the last hot temperature, or the current index minus the last hot temperatures index. So index minus last hot temp. And then we'll return that. Okay, surprisingly hard on different operating systems just because my control and command keys are switched. So, okay, let's run this and see if it works. Or if I've totally broken it. Hold on. Control C. Okay. Oh, there we go. Fix all of that. Run that. Okay, list object cannot be interpreted as an integer. Okay, so let's practice some systematic debugging. I'm gonna look at the chat. Stack is empty. I think that was, okay, it was like 3 ago. List object cannot be interpreted as integer. Check the end limit of the for loop. Should be in here. Check line in line 5. Oh, geez. The range of the length. There we go. Thanks. Okay, so we've got all zeros, which means it's not working. So let's drop this in Python Tutor and kind of walk through it together. All right. Okay, so we've got these temperatures and we're going to loop over them. And then I want you to kind of watch this part so that you can diagnose the logic errors in this. So our index is 0, our temperature is 73, the length of the stack is 0, so we're just going to add 0 to the next list. Then we're going to keep going. Well, temperature is now 74 and index is 1. We're going to append 1 to the stack. And then the length of the stack is not 0. Oh, you know what? I think I see it. Does anyone else see it? Basically, at this point, we want this and this to both read 1. But I think that we're checking like the temperature value. We're trying to see if this temperature value is less than what is at what's in the stack, right? And so we need to make a change. Does anyone know where that change might be? Or if you have a question about like what you're not sure, like what is the point of this or what is the point of that, you know? So what I'm checking here is basically, you know, so long as my stack's not empty and my temperature should, the temperature I'm checking now, 74, should be less than the last temperature that I checked. So I want to keep indices in here, but I need to use these indices to access daily temps. So I'm going to try it this way. So now we've added this, we've added 0 to our stack, and so our length is not 0. Temp is 74, and so now I'm doing this check, and temp being 74, temp is less than daily temps at the last thing, or it's not less than, it's greater than. So then we're just going to add the next stack, and I think that that's actually the problem here. Actually, that I needed to, once I've found a hotter day. Okay, so now we're here and we're in the loop. So we hadn't really gotten into this loop before. And what's in our stack right now is a 0. And so the 0th index of daily temps, which is 73, is less than 74. And so we're taking the last hot temperature, and then we're saying that the output of index, which is 1, minus the index of the last hot temperature, which is 0, is 1. And so how many days will we have to wait? 1 day, but kind of put it in the wrong spot here, right? So there's an error here, but if we kind of watch this go, you might see the dynamic, right? So now we've got the index 2 in here, and that's got 75 in, right? So this relates to this. And we're about to provision temp. So now temp is 71 here. So we're going to just add it. And then we're going to just add the next one because 69 is smaller. So is 72. And, oh, wait, hold on. Okay, so what's happening here? Let's watch this part. So while the length of the stack, so we've matched that condition, and temp, which is 72, is less than daily temps at stack of -1. So 4, the thing in the fourth index, right, is less than or than whatever's in temp. So that's 72. So basically we're looking at 69, and we're about to go into it. So we're gonna pull off 69's reference from the stack that was here. So this referenced this element. About to pull it off. And then our current index is 5. So this is going to be our current index minus the index of the thing that we just popped. Okay, so that's 1. So this is correct, but it's in the 5th and not the 4th. Does that make sense? So we can kind of see this happen again. 5 is being changed because we found, well, let's see, hold on. So yeah, so we're still in our while loop and we're kind of going backwards, and we're checking to see if 71 is less than 72, or at least we should be. So temp, which is 72, is wait, sorry, 72. Yeah, that's in index 5, right? So temp is 72, and then it's larger than 71, which is what our last hot temperature would be. But instead of changing it where 71 is supposed to live, which is index 3, we are changing it at index 5. So we just modified index 5, even though we just put our last answer there. So can anyone tell me what I need to change to modify the correct spot in our output array? Should it account for when the temp is equal? Well, when it's equal, it's not hotter, so no. Any other thoughts on this? Okay, so basically the problem that we're dealing with here is that we want to change the spot in the answer array that corresponds with the temperature that we just popped off, because the thing at the top of the stack is the thing that we're comparing with our current temperature. And our current temperature's index is what we have. And so what we want to do is find how many days after. And so that's our current index minus the last index that we found. So let's check this. Okay, so now we've got something in our stack, and the temperature is larger than the thing at the end of the stack. So we're going to pull that off, and then we're going to edit the correct place and say that it's 1. All right, now we're going to append the first index to the stack that represents this temperature. And then we're going to compare that temperature with the one that we're on. Our index is 2, and so comparing 75 with 74. And so then we're going to change our output. We popped it off the stack, and we're going to change our output array at the index of this last temperature, which was 1, so it's here, to be 0 minus 1. Okay, so now we're about to get to 75, right? And so we're going to skip it for a little bit. We're going to add 2, 3, and 4. But then when we get to 5, 5 is hotter than 2 is. And so this index of the last hot temp, that's 4, basically we're gonna set it as its index 5 minus its index 4 minus the current index, that's 5. So that'll set that one to 1, and then it will go through and it will set 3 to 2, and then it will go through and set 2 to 1, but it didn't do that. It just added 5. So let's see, why did it do that? Let's look at this state. Because, well, 72 is not hotter than 75. Sorry, I jumped the gun on that. All right, so we still haven't found it. So we're adding 5 to the list. How many days till it's hotter? Well, now 76 is hotter than 72. And the output, we just updated it to be 1. So there's 1 day after. And then now that we found 76, we're going to compare it. And we compared it with 75. Since it's hotter, we'll set that the index is the current index, 6, minus the index of the last temperature that was that hot. And that's 2. And so it's 4 days away. And that's how we got our 4 here. And then we're appending 6 and 7. And those days never have anyone that's hotter, or any elements that's hotter. And so we'll return the output. And there you go. And so, you know, if we edit it and we put, you know, 80 in here, then these two shouldn't be 0. They should be 2 and 1 respectively. So we'll go to the end there and just look at the output, and it's 2, 1, and then 0 for the 80. So we can kind of see it change. So this is kind of how we're using a stack, and it's kind of like having 2 pointer variables, only you're able to keep track of more than one thing in your sort of second finder pointer variable. And so you can kind of go back over and compare all the elements that need to be compared with the current element, which will allow you to traverse over the list linearly, because you're not having to do multiple comparisons. You know, you're not having to kind of go over the list over and over again to find certain things, right? So a stack kind of allows you to create these little windows, these sort of micro windows to find things, so long as you can index into this list to make your changes to that list. So questions on this solution? I don't know if this was the best pseudocode here to follow. No, Aaron says no questions. Cool. Okay, so that's stacks. Again, I really do recommend Visualgo. It will talk about things like stacks in the linked list module. If you click on linked list and you escape, it starts with a linked list. Never seen them before. This is a great introduction. But the stack is represented here, and you can see stuff like push operations and how they work. Oh, there. Push, go, do it. Right, it's not doing it. Pop then. That's what a pop-up operation looks like. It's easy to take things off the top because you have a pointer to the head and you have a pointer to the tail. And if you want to add something, that's what it looks like. It's really just the one operation. And so it's in terms of time complexity, it's better than traversing through an array or having to deal with like adding something to the end of a linked list. And that's really because we have a pointer to the top of it. So yeah, so that's kind of how to solve the daily temperatures one. Now, that same pattern that we see here, where you have like a for loop and then a while loop to kind of create that window, you're going to see that again in a lot of the modules that you have, a lot of the problems and a lot of the stretch problems. So just keep in mind this pattern here for index and range. Well, not necessarily indices, but for loop followed by a while loop that is about the length of the stack and the comparison itself that you're doing. Okay, well, so we're gonna do some group exercises. I've got a new challenge for you if you've done all of the run length encoding and tic-tac-toe too and all of that. I've got some new ones. So in the beginning of this group exercise, what I'm wanting you to do is talk about the hardest bug you've ever fixed. So take a minute to think about it, and then the other people in the chat, if you could basically just ask the other person a follow-up question. Ask them a follow-up question almost like you don't believe that they ever ran into this bug. And so try to ask such a specific question that if they made the whole thing up, they wouldn't have the answer. But if they didn't, they'd totally have, the answer. If you can't think of anything that's that specific, just ask questions about like, well, how did you solve it? What tools did you use? That kind of stuff. So yeah. So that's what you're going to start off the group exercise with, and then hands in the air if you have done run length encoding 2 and tic-tac-toe 2. Okay, so no one here has done both of those. Who's done run length encoding 2? Victor has, Aaron has not. Okay. Have you done, who's done run length encoding 1? Okay, it's gonna go. Cool, y'all have done run length encoding 1. Okay. Well then let's jump into a breakout room. Well, you don't have to jump into a breakout room. We could just do it here because there's only 3 of us. But we can, let's see, let's go ahead and do run length encoding 2. Nope, this one. Okay, run length encoding 2. Does anyone want to practice stacks more than they want to like build upon a question? Is there anyone who's like really into practicing stacks? Okay. we might have more fun doing something like this noisy signals challenge together. Okay, so let's talk about the noisy signals challenge. I'm gonna go ahead and just share my multiplayer link with the group. And then let's get together and solve this as a group. Y'all should turn your cameras on though, so that I can see your wonderful faces and know if you're confused. And then I think Christopher Martinez, where are you? Okay, so let's kind of take a look at this problem. So the idea is that you're reading a digital signal coming from a light sensor connected to a pin on a microcontroller. Has anyone done this before? No, no. Okay. So this is actually kind of what you get when you literally like connect a light sensor to a microcontroller. You essentially you just get a list of integers, right? Like integers come in off the pin and it's just like 83, 77, you know, just kind of shouts random integers at you at an interval. So we're going to say that that interval is perfect and that it's 1 millisecond of time. So every number in one of these lists represents a single millisecond. And it's basically what the light level is. So this is pretty typical of like a microcontroller. It's like a range of 0 to 255. Like I have one on my desk that does this exact thing. And so something that happens with these is that you get a lot of random noise, right? If you look at these examples down here, you'll notice that it's like 4, 5, 108, right? It's like a single point of light like hit it during that millisecond and then it kind of went back to normal. So it's like a thing that happens with, you know, light sensors. So there's a fair amount of random noise and a distinct period of time where a halogen light is turned on. That's the idea, is that we're turning on a halogen light. If you aren't sure what a halogen light is, it's basically one of those lights where like, it's kind of like a street light, you know, how when you turn it on, it's like zzz, and then it starts to slowly get brighter and then it gets to like maximum brightness. So that's the kind of light that's turning on. You can't be sure how bright it is in the room, like, you know, at night and during the day, it's different. And so there's some examples here: a dark room to a dim room, a dark room to a bright room, and a dim room to a bright room. So all we want to do is write a function that will return the length of time in milliseconds that the light is on. So yeah, that's what we're doing. Who wants to get started? I did want to do these, the group exercise, since we didn't break into a breakout room. We'll just kind of go one by one. And I'm thinking, so we're going to talk about the hardest bug we've ever fixed. So let's start with that. Take 60 seconds, think about the hardest bug you've ever fixed, and then tell me a 2-minute story about it. Okay. Victor, how about you go first? Because I don't think Chris is here and Aaron went first last time.
Oh, all right. The hardest bug I ever had to fix was in my data structures class. We were working on implementing a binary tree. The catch is that it wasn't a binary tree of numbers. It was a binary tree of recipes. And the thing that made it hard, for me at least, was determining if you delete a node that has 2 branches attached to it, what node would have to end up replacing the deleted node. So because of that, I kept on getting a tree that looked like, it was like wingman sandwich, and then vegan banana pancakes, and then just potatoes. And it was really awkward because like it's supposed to be in alphabetical order from like ascending to descending. So that's why I was like really confused. So, and the hard part was that because it's a node, it's not like an integer or like its own defined structure. You can't just be like, oh yeah, just print out the node. You have to like get the specific aspect of the node and then try to determine what's its next and what's its previous. But eventually I was able to determine that it was one singular less than sign that I did not notice that made it that would get the, so what would happen is you would get the largest of the left branch, copy that data, insert it into the node that you want to delete, call it a day. No, I did it on the right. It was the less than symbol. It should have been greater than. Got it though.
I mean, I did that one, so. Yeah. All right. Christopher, how about you tell us about the hardest bug you've ever fixed?
Hello. Okay, hold on. Sorry. Hello. Okay, so the hardest bug I ever had to debug was for took what was it, mobile applications course. It was like CodePath Android course, and we were doing a Instagram like mock, like pretty much an Instagram clone, and we had to use an API that took the photos from the database, and because everything else was going in properly from the API link, and but the photos were not coming in, and literally it took me forever to figure it out. But turns out Android Studio wasn't allowing. It needed the HTTP to be HTTPS because Android Studio only allows the secure form of encryption, I guess. So, I mean, but Android Studio wouldn't say that directly, so I had to literally like go all around like Stack Overflow until I found that. And I mean, the fact that it was just like a letter difference really stressed me out. But yeah, that's probably the most stressful debug I had to go through. But yeah, that's it.
Got to be the most common like application developer type bug. One character off from the package name or something.
Yeah. So.
Yeah, totally. All right, Aaron, tell us about the hardest bug you've ever fixed.
I've been trying to think of what's the hardest bug. I can't really think of a particular example. Like, I mean, obviously I've dealt with bugs all the time, but like, I can't think of one where it's like it took me days or something. Like that was more of an issue or having to change the code itself rather than like a simple mistake. Can't really think of one, to be honest. Or a particular one, rather.
You definitely failed that interview question if you say that you can't think of one.
Yeah.
Yeah. It's a common interview question, so you probably want to have one ready. Like one that's really good is if you ever had to fix a bug in a library, if you ever had to, you know, find like, if you ever had to find like something undocumented that was, you know, like kind of working in a way that isn't stated anywhere in the documentation, but like somebody had to write it up on Stack Overflow?
Well, if it's something in that regard, I kind of had to deal with something along those lines when I had to build a website for a class. And the thing is that it involved actually making user authentication. And for that, we would have to use Firebase. And the thing with Firebase is that it's relatively new in comparison to other like frameworks you can use for user authentication or other components for a website. So when it came time to actually trying to like look up documentation or resources on like how to make a user, how to communicate with database, how to deal with the aspect of security and such, in my opinion, it was so poorly documented because it was like basically it was like trying to read instructions, but it would always be partial and it will always start in the middle. So what I had to do to be able to even figure out like how to start building up like how to use basic user authentication was basically watch a bunch of different website posts with the different steps at different points and just put them all like in front of me and kind of Frankenstein or reverse engineer like, okay, this seems like this is before that one. This seems after, so okay, 1 and 2. Oh no, wait, this is even earlier. Like, make some weird timeline and basically trial and error until like, I got to store a user in my database, so I'm getting somewhere. So,
All right.
yeah, that would be one of the biggest ones because that kind of behavior learning went throughout the entire project, like just every single thing. Like, we need to do this. All right, let me start from scratch all over again with this weird timeline of steps.
Yeah. No, that's actually a really great story. A lot of times in production, you kind of just get like handed a tool or a library, like, we implemented this across the whole company and now it's broken, fix it. Bye. There's no documentation. You're just like, and then, you know, this blog post, but no, like the official docs are terrible.
Right. Yeah, exactly. Yeah, exactly. Like the official documentation's like, this is so random. Like these are all a bunch of terms that don't really apply to what I'm supposed to be doing. Like this isn't helping.
Exactly. So it's pretty common and great, like, you know, real world skill to have. So I think that shows like a really good one. Okay, that's perfect. Okay, so you've all got a link and we're all in here. So let's start talking about how do we solve this problem here. Chris, I don't know if you were here, but basically we're looking at reading we're reading a digital signal. It's coming in from 0 to 255 that indicates a light level. And what we're trying to figure out, oh no, Victor's gone. He'll come back.
Oh.
But anyway, what we're trying to do is find basically how long has a light been on. So from the time it gets turned on to the time that it got turned off. It's a halogen light, so it's gonna grow in brightness over time, like this. And then it'll get turned off at some point, like this. So how long has it been on? So yeah.
And at what point do we know it's off? Just the end of the array?
No, so basically all this represents is a light level. You have a digital like signal that's coming in off of a light sensor, right? And basically you're getting a number, and that's how much light the light sensor thinks is in the room. And so this room is a dark room, It starts off very dark. This room, pretty dark, but this room starts off kind of dim, right? It's fairly bright, but then when we turn the light on, it's like way brighter, right?
Yeah.
So we don't know for sure that the light level is going to be over a certain level to start. And we don't know that it's going to be under a certain level to start, right? Like these start pretty low, but this one starts at 40 and 50. We also don't know that every single data point is valid because, like they actually are in the real world, noisy, right? Sometimes like one, little spark of light kind of shows up or whatever in the room for like just 1 millisecond, and your human eyes don't even notice it, but like your computer noticed it, or it just sent a signal for some reason.
Okay.
Yeah.
So this number has to do with the amount of time, because the first one is the longest. It's 24 milliseconds, but it seems like the shortest list. But it has huge numbers, so that.
So
So is there a correlation between the numbers and the time, or no?
yeah, so every number is 1 millisecond of time. So the first 4 was the first millisecond. This is millisecond 1, this is millisecond 2, this is millisecond 3. So the answer for this example is 24 milliseconds. The light was on for 24 milliseconds. In this one, it was on for 14, and in this one, it was on for 15.
But so every single one here is less than a millisecond.
It represents 1 millisecond of reading. So this is one measurement, and it lasts for 1 millisecond. So every number is a millisecond, and in that spot is the light level.
But wouldn't example 3 be more than 15 milliseconds then?
No,
Oh,
because it's a dim room to a bright room. So the room starts out fairly dim, but not as dark as these other 2 rooms. These rooms, they start super dark. Maybe it's nighttime in these rooms. But this is like a daytime room that we turned on the halogen light bulb in.
okay. I think the trick here is just figuring out how to convert these numbers into like time, right? Kind of.
Well, so we know that they are all 1 millisecond. And what we really want to do is figure out how many milliseconds the light is on. So you don't have to like convert them into seconds because they're not seconds or milliseconds or anything. This doesn't represent time. It represents the level of light in the room at the
Okay. It's kind of confusing how to even approach this.
let's call that measurement. Anyone want to jump in? Like,
Well, I mean, the issue, yes, there's quite a few parts, really. Because like one is that we need to somehow figure out what's kind of like the range of low values and the range of high values, so we can distinguish between on and off for starters. And then how to get rid of noise, or when we can start accepting the reading values as actual values rather than just one-offs. Do we? From 0 to 255, okay. There is a range. Uh-huh. So what would be a good difference of value? So like if like from one value to the next one, if it's 30, would that make a big difference on the lighting, or would it have to be 50?
Well, I mean, it doesn't sound like there's a strong answer to this, so maybe we should make up a value and see what happens. It sounds like though you're thinking that there's a difference value, like some difference value.
So from what I've noticed is that I forget the word, but the number of digits is off. For example, in example 1,
Is it?
yeah. So in example 1, the smaller numbers are one digit, and then the numbers that we assume are the light are larger than that one. So I'm thinking maybe that's a place we could start.
Maybe. Kinda.
Because even if we apply it to example 2 and 3, the largest number you get. Whoa, hold on. Okay, so it could work, but in example 2, we get that random flash of 100. So that kind of messes things up a little bit.
Well, that's where the discerning if it's noise or not comes in, right?
Yeah.
Like after how many consistent range of values does it need for it to be like, oh, okay, so this is consistent, you know, like should be 3, 4 and up, and then it's like, okay, it's been 3 times where we have something along the same range, so this is valid, not noise. Or how will we discern what is noise?
From the looks of it, I think you're right about that. I guess we could kind of say like if it's more than 3, then we could like kind of start counting it as it being the actual light rather than like a flash or something else.
Right.
All right. So you want to jot down that plan so you can kind of engage with it?
Sure. Wait, did I click the right link? I can't see what you guys read on my screen.
I think we're all here, right?
Here, I'll drop it in the chat one more time.
All right, thank you. There we go. So to run through, our game plan is we want to, well, first things first, we have to determine whether or not the light levels we're looking at are actually the light source, not like a random flash. And we said we check that out by confirming if like the next 3 light levels are roughly the same size, then we could count it. Sure, start pseudocoding that out. Oh, I'm really bad at pseudocoding, so if you guys have any like complaints, let me know, please.
Oh no, I'm the same. So.
All right, I guess we go in together.
Yeah.
All right, so that's thing 1, and then thing 2. Oh, that's step 2 actually. Step 1 is determining what qualifies as a large number. I still want to go with the aspect of it being like, what is the common like size of the digits? Like if it's 2 digits or 3 digits.
Well,
Or what's up?
the thing is that first we need to figure out what's the starting state, right? Like from the beginning, is the room bright? Is it dim? Is it dark? And then from there, depending on the next chunk of like consistent values, discern if it's like, oh, it got brighter or it got dimmer, and then kind of go from there. So like be able to establish like up to it, like divide the entire array into like groups and then label those groups into like what's the state of the room there and into what it changes after that until it's kind of over, right?
I don't follow on the last part. Could you explain?
So like let's look at what example, or actually, because no, never mind, because the question is just like for how long the light was on, right?
Mhm.
Oh, okay.
How are you going to figure out whether or not those light levels are next to one another?
A stack. Yay or nay?
I mean, I'm interviewing y'all, so I can't give you hints like that. That would be cheating.
Hmm.
All right, so everybody's pretty quiet. What are we doing here?
I'm still trying to wrap my head around the problem, to be honest.
Mm-hmm. So we've got a couple of. So let's write out the 3 problems, really, or like however many problems. I don't actually know if there's 3. I'm not trying to give you a hint.
So we know for a fact that it's gonna get brighter since the whole question is when the light is on, right? So like we can assume at some point it will turn on, right?
Right.
Yeah, so it's can the light is only going to be turned on once, right? Or can it be multiple times in specific time frame?
For this example, we're only turning the light on and off one time. But there might be noise.
Right. So then if we went with the assumption that there's no noise, like just for the sake of argument right now, then you could split the entire array into like 3 groups, like the starting group, the group where the light is turned on, and then when it's turned back off. Now, the other question is, or the other situation would be that the light is turned on from the beginning and then it's just turned off.
For now, let's assume that maybe we're creating like a scientific instrument to be used to test the length of time lights are going to be turned on. So we know that it's going to start dark and end dark, but that in the middle there'll be a bright section.
Right. So then, in order to identify each group, it would be a matter of kind of getting like a bit of an average of sorts for like a consistent range of values. And then when that value or average like spikes up consistently, we would know that we're in the range of values the light is on. And then when it spikes down, that's where it's off. But then that leaves the issue of discerning if there's noise or not before deciding if from this group to that group is like on or off of sorts. I'm just brainstorming, don't mind me. Like, if you have other ideas, feel free. Average, I guess. Would that be moving or not? Chunks of 3, 4.
Maybe we could have 2 stacks. Ooh. One stack would be taking in the smaller numbers, and then the other stack would be taking in the bigger numbers. And the way we could confirm whether or not it's a flash is if so we have the first stack, and once we get to like using example 1, so if the numbers are like roughly the same area, which we'll define, we could append them to that stack. And then once we get to a number like 77, we would check like, oh yeah, okay, so this number is like way bigger than like the popped off values, right? Let's append it to the other stack that takes care of the larger numbers. And then we would know whether or not it's a flash or not, because from what I've noticed, the flashes only really stay on for at least like 1 millisecond. Okay. So if we confirm that the next index, if it is within the smaller stack, we pop off the value from the larger stack. So it's back to empty. And then we could just keep on using that format to just get the larger array. I mean, the larger stack, sorry. And once it's back to normal, or once the whole the whole list is run through, then we could just return the larger stack and call it a day. What do you guys think? Yay or nay? Sorry, I was thinking about that.
Okay. Actually, that might work. Yeah, because you can just peek. Like if you get a random flash, you can kind of just peek if like because you say you have two, one for larger values, one for smaller one, right? So let's assume you're starting with small ones. But the thing is that how
what?
Would it be basing it on the previous one it looked at, right? So like going back to like example 1, like let's say that you have all these small ones into your stack, and then you reach here, you're at 5. And then you look at 77. So you would just compare the value of 5 to 77, and you would be like, okay, there's a huge difference. So this has to go into the bigger one. And then let's assume this is just 5 for the sake of argument. This is just a random flash, right?
Sure.
So then at that point, you would again compare this 5. Like what would you do in this case from here?
So what we would do is, so wait, let me write this down because that's a little weird. So it'd be like 3, 4, 5, and then we'd add 77 to the larger stack.
Right.
And then the new number we got is the 5.
Right.
Yeah. So what we do is we'd peek it. And so it'd be an if statement. It'd be saying if the larger stack is empty or not. And then from there, we check whether or not the peaked value, I just had it, hold on. We check if, so we check if the value is within the same magnitude or not, because again, the pattern I noticed is that there is a difference of at least like a digit. The smaller ones are of digit 1, at least in the first one, and the bigger ones are of digit 2. And they all kind of follow that trend in the other questions. So that's kind of what I'm basing it off of. So if we check the magnitude of the numbers and they don't align, then we could just pop off the number of the big one. So that way it'd be back to empty again.
Oh, okay. So you put the random 77 flash, then you see the 5. You would notice that it's a huge difference. So you would pop off that previous 77 from that other stack.
Yeah. And then we would append it back to and then we'd append the 5 to the smaller stack. Right.
And then you would go on your way. Now, assuming you bump into the proper lighted switch, right?
Yeah.
This one, right? 77, you add it, another 77, it's within range, so you add it, and you keep on going until you reach the 7.
Right.
So what would you describe would work if it was like on the individual basis, right?
Wait, say that again?
So what you describe would work because you're just comparing it like to the previous one, right?
Yeah.
So what would we need to add or do so that in this case it's proper because we have the big one and the small one, but it's because it's actually over, not because it's a random flash, right? So like if it continues to behave as you described, it would just pop this off instead and move on with the 7, right? Like we would lose this one last value. Now the thing is that I guess what we can do is we can just check the size of the stack
and like see if it's like bigger than like 1 or 2 or something.
Yeah, that's true. We can have a counter of like how many times we've pushed into the stack, and we just decrement it with a pop. Like if it's bigger than 1, we know it's the proper length or like chunk.
Yeah.
Oh, okay. Yeah, that works. Okay, yeah, I think that works. Seems reasonable.
Now, how do we implement it in 8 minutes?
The question of the million. Uh-huh. Does Python actually have the stack data structure? I'm assuming it does, right?
It's
Or
the list.
it's the list. It's just like just use the list instead.
Yeah, dot append, dot pop, dot peek.
Well, that does explain why it does have those methods, I guess.
Yeah. Optimized to be O1 in Python. So.
Hmm.
All right, let's try.
All right. So first, we need the stacks. Yeah.
Let's just make it 0. Why not? Wait. Yeah, we'll just do that.
Hmm. Does it need to be a smaller stack, or can it just be the current small value?
I want to say stack just in case we get that flash, then we don't, or just in case.
Okay.
Oh, wait,
Because we never pop from the small one, right?
no, we never pop from the small one.
So
But
we're
we do.
looking at the last small.
However,
value.
we can if the situation demands. Instead of just no, I'm not sure actually where I was going with that.
I mean, we can keep it as is. I was just wondering, like, do we need one? I mean, we can just take it off in the end if needed.
Also, let's just make it an empty list. There we go.
And then we need the big stack.
Yeah. Wait, dark stack. Wait, did I name it that?
No, it makes sense because it only takes account like the dark value.
I meant to put small.
Yeah. I mean, it's just more particular to the question, right? So
sure.
Changed it for fun.
All right. So, okay, this is another good question. Are we gonna do this based off of index or based off of number? Definitely number, right? Yeah, because I don't see us needing to go back between another number. That's why we have the stack in the first place. And we wouldn't really use indexes because, again, stack, it's our best friend.
yeah, because the stack, we only need the length of the big stack because that gives us how many milliseconds it was on.
Yeah. All right.
Yeah.
So here's the tough part. We gotta, for light in light period. Ooh. All right. So here's where we actually have to implement
it would be measurements, right?
In measurements. Whoops, my bad.
Yeah.
Now here's the part where we have to remember what I said like 5 minutes ago. Yeah, by magnitude 10. So that's to be magnitude 10 larger. Yeah.
Right. Yeah.
3 to 77. That's a difference of 10 in digit. Yeah. Okay.
Yeah, so if it's at least like magnitude of 10 from the previous small number is larger than that, it should be considered large.
Wait, actually, I've never tried this out. I think we might have to start off from 1 because our list both of our stacks would be empty in the beginning, right?
Yes.
Y'all remember the pattern?
What pattern?
The stack pattern?
No.
So here, let me pull up daily temps. If you look at Zoom, you can see daily temp.
Oh, stack length greater than 0. Right, because then we could just append it afterwards.
Like 4, and then usually a while loop where you're kind of accruing things, but you know, yeah.
All right. Yeah, we could do that.
Yeah, it's because, yeah. I'm gonna-
And then what we'd want to do is kind of use that as like a temporary. Okay, so now we have our number. And now we need to do that while loop business. So while our stack length is greater than 0. Okay. Question is, which stack length are we looking at? Stack length smaller because our larger stack length can be 0. That part is not determinant of whether or not our loop should be running or not. Okay. Now I'm starting to see a few problems with this. Because now we have to determine like what's the normal magnitude of the numbers from the beginning. It's easy to look at it from the middle and say, hey, you know, like half of these are length 1. Okay, this one's length 2. These are all length 2. All right, we know what magnitude it is now, but now we need to determine it from the beginning of the program. That's a little bit harder.
Well, you mean determining if it's like a small value or not, or?
Yeah.
Well, we know that it's always going to start as a small value, right?
Mm-hmm.
So we can just start the dark stack with the first element of measure.
Ooh, I see. So from range 1, and then is equal to measurements of 0.
Yeah.
Okay. And now here's it. Oh man, I should have wrote this down.
Well, the length of dark stack.
One sec. What happened?
No, nothing. I'm just reading. So, what would be our base case? Where will we stop? Well, technically, we would stop when we get to the larger values and then go from lower ones consistently. Because it's like, okay, we already went through the switched on part. But how would we know that? That's the question.
I have an answer to another question though. I just thought of it. So the way we'd actually determine magnitude of a digit without like converting it to a string, then you know taking the length. No, that's too much work. Instead, we'll just we'll do double divide by 10. So that way, if it's 1, we should get 1 or 0. I'm not quite sure, but that should be correct in determining if it's larger than one of 2 digits compared to 1. I just remember the math behind it because I'm more used to Java, but And why don't we do dark stack? Okay. Now here's another question we have to decide on. Do we want the increment? Do we want the loop to be purely based off of? Wait, no. I'm so lame. All right. Greater than 10. This is going to be. This might look a little ugly. I apologize. So let's just pop that bad boy over there. Is less than temp. You can really tell I do Java. All these parentheses.
For Python.
What do you guys think?
So,
What's
okay, so you're getting the last number from the big stack, and you're dividing it by 10.
Oh, whoops. I have these mixed up. My bad. There we go.
Wait,
And this one should be light stack.
should it?
So this way we're actively comparing the sizes of the digits while we're in the for loop. So the while loop is going to be used to actually add the numbers within the stack. Wait,
No, but
no, I'm confusing myself.
because the one that we need to find is the dark stack, right? Yeah. No, so I was just asking like why we're dividing by
By
10.
That number is used, the //10 is used to confirm. I mean, not used to confirm. It just gets the. I'll print it out. I'm really bad at explaining this part. I'm so rusty. So measurement 0, right?
Yeah.
Okay. I'm just gonna copy this for now. I'll paste it back in. So so print dark stack -1 divided by 10, and then we'll just call it on okay. Example 1, yeah. 0, none. Okay, that's perfect. Now, if we go to index 2 of wait, not index 2, sorry. If we go to index 10, 9, my bad. If we go to index 9 of example 1, then this number should be different as well. Wait, what? Did I mess up on something? I think I may have.
What did you expect was going to happen?
I expected it to be a 1.
Okay.
Wait, no, that's right.
Is that because are you trying to
Dark stack is empty, right? Or well, you made it not empty, but
Yeah.
I'm kind of lost on what you're.
My bad. So what
Right.
I wanted to do originally is I wanted to take a number like 7, right?
Uh-huh.
And I wanted to find how many digits there were
Uh-huh.
in the number. So if we divide 7 by 10, we should get 0 if it rounds down like Java, which I'm not sure if it does or not.
The double slash in Python does floor division.
Right.
Or division?
Yeah.
Oh boy. Okay.
I'm trying to remember the name of the operator you want. You're basically trying to figure out the magnitude of it.
Yeah.
Let's see. Magnitude. Or how many digits? Mm, mm, um, you can always cast it to a string and look at the length.
All right. Guess they're doing that.
Back to square one.
Mhm.
So it looks like the difference, it looks like what y'all are trying to really focus on here is getting the difference or the delta, right? Between the typical dark stack value and the typical light stack value.
Yes.
Mhm.
So there's a couple things you could do here. You could maintain an average just in a variable, which would mean maintaining a total and a count of dark values, and then determining whether or not there's like, you subtract one number from the other number, and you can do stuff like getting the distance between those numbers. So, I mean, you don't have to modify the number. You can just say, if 5 minus 4 is less than a certain number, or greater than a certain negative value, right?
Mhm.
Maybe 10, maybe maybe 10 and negative 10, right? So if it's within 10, then it's within the same sort of range, right? So that could help you to find your like which bucket you're in. Are you in the low bucket or the high bucket?
Mhm.
Right? But since you don't know the value of the high bucket, like you don't know if it's 30 higher or 100 higher or 200 higher, right?
Right.
And if you look in the first one, like 5 to 77, that's at least 60.
Yeah.
In here, 4 to 100, that's more than like 60. In here, you don't get a swing of greater than 60 here, but you do get a swing of greater than 60 here. So like you could kind of make some guesses about like what's the range, what's the size by looking at the input data. A lot of times if you are doing something like embedded systems programming, you just want to look at the data, right? So you can make that hand wavy call. And then after you kind of get to the point where you can like reliably find the start, then you can maybe apply, like you can write another function later to kind of really like dynamically figure out what the jump is. But what I recommend is in this situation, just look at the data and see like what's the minimum delta that you're really dealing with here.
Okay.
So there's that. And then there's determining which bucket the number goes in, right? Does it go in the bright bucket or the dark bucket? So once, like imagining you have a function that just tells you which bucket to go in. And then if you add it to the bright stack, then you find another low value that doesn't belong in the bright stack, and you know that you have a flash.
All right.
Right.
And so then you can pop the bright stack once you determine that you have found a flash. And then if you're not finding a flash, then the next number is more, and then so the stack is larger than 1 at this point, and you keep adding stuff. The stack's larger than 2, the stack's larger than 3.
Yeah.
Then it's going to be, a real light turning on. Right?
Yeah.
So basically, you want to discard outlier values. It's a similar mechanic, but you still want to go one by one, bucket them, and then if you start putting light values in the light bucket, but then you have to stop, you can call that a flash.
Okay.
And then once you add all the light values to the light bucket, you have the length of the light bucket.
All right. I need to go now, though. I'm sorry.
That's cool.
All right. Take care, guys.
See ya.
Yeah, see ya.
Bye.
Bye.
Yeah, kind of need to leave soonish too.
Yeah,
But let's see. We had okay. So we have the dark stack. And we have the light stack. Oh yeah, we have this inside because we started with the first one.
Mhm.
Light stack, it's just empty. So then for
Here, I'll write you a function with you know, so
now, okay, what was the while loop for? Range. Sorry, this heat is killing me. Doesn't let me think.
So I wrote you a function called light is on, and you pass in the light value you want to test along with the last value of the dark state.
Right, and then if yeah, so it's gonna return light minus dark. Yeah, okay. Got a little helper function. Yep. So it's gonna make me go through each one for sure. But then what was the while loop for? Do I need a while loop?
Well, so
I don't think I need one, do I?
basically what you want is you want to determine whether or not you need to clear the light stack by seeing if the light is on twice in a row.
Right, so I basically need to traverse the measurements like once, right?
Mhm.
So since I'm just comparing it at most with like the previous one or like the next one, it's just traversal. So I don't think I need a while loop.
So start with no while loop then. How do you get them all in there?
So moth. Yeah. So
Yeah, just start with just bucket them. Don't worry about the noise. Just put them in the right one.
yeah, so we're starting with, or actually it was from 1. So we're starting with that one. So if light is on, given the the light which should be.
You're,
Oh, but we don't know light yet.
so
Should just be light if
Oh,
less than 60. Or no?
because light is a current 1, right? So, and then dark.
so this is going to be 1 the first time you run it, and the second time it'll be 2 because it's an index. Really,
Oh, right. Yeah, index. Yeah, index. Yeah, it's true. I kept going with the notion of what we started with.
yeah.
So it would be measurements. So, that is on measurements light stack. Oh, right. Yes, index. So, yeah, so if that's the case, if the light is on, then like stack to append measurements index.
Mhm.
Yeah, else the light stack, no, the dark stack. We're gonna add that value. That's a small one. And then we would need to check.
So in the name of incremental testing, let's just imagine that example 1 is our only example. It doesn't have a flash. It doesn't have anything weird going on. So let's make this work for just example 1.
Okay.
But yeah, we just got to finish it up.
Yeah, because I know it's missing things for sure.
But if it works for the first one, then we can build on that, right?
Yeah. So, okay, so it should go through the entire array. If the light is on, it's gonna put it into the light stack. If not, it's gonna put it into the dark stack, which is fine because, as you said, we're assuming there's no flashes for now. And then at the end of it, it's gonna return the length of the stack, the light stack, which should be how many times we had the light on.
Yeah. Okay, so let's run this, see what happens. Okay, 24, and it looks like that first one is
24.
So you're almost there. So now we just have to think about this next case, right? So
Yes.
you've got your base case.
Right. So now it's the fact of the possibility of a flash, and also we're going with the assumption that a flash only lasts 1 millisecond. So then, if the light is on, we just add to a light stack. Nothing else really happens, but we also need to check if the light is on, and the length.
Wait,
What?
I'll give you a hint. It's not in this one right here that you put this logic. If you look at the daily temperatures thing, kind of do a check basically before we do the append. We want to do a check to see if it's a flash right there.
Huh. So if the what is the current value, I guess? Or okay, if it's a flash, then that means that the current value is way bigger. But the way we check for the flash is if if there's only one.
Well, you could do it here, or you could do it. It's not going to be on this line.
Well, it has to be a bigger value, and then it has to be by itself.
Mm-hmm.
Doesn't the light is on check if it's a bigger value?
The light is on check is if it's a bigger value, yes. So in, let's say, example 2, you have the light is off, or you put the first one in there, right? You put it in dark sky. And then you're on 5, and so and the light is off, so you make an append to dark sky.
Right.
You make a call to the light is on, and it's on, so you append 100. Light. And now you're on 8, and so when you call the light is on, it says that it's off.
Right.
So where would you go if the light, you know, once we're on this part?
Oh.
Which line executes next after line 37?
Yeah, the append.
Yeah, but which one? 38 or 40?
Oh, well, I mean, if it's at that point, it would be 30 or 40.
There you go. It'd be 40. Once you get to this 8 element, it doesn't think the light's on, because the last element on dark stack is what matters here, right? You're sending it 5 and then 8. That's what's being passed into light is on. This will be 8, and this here will be 5. And we'll jump down into line 40, and we'll append the element to dark stack. But at that point, we need to do something else as well. What do we know about light stack at this point? Like, we're about to append 8 to the dark stack. And light stack looks like what?
It has the one element, which is 100.
Right. And we know that flashes will weigh like length 1, right?
Yes.
So that's a pretty decent check. So what is light stack's length?
It's 1.
Right. So in here, you could put a check.
Damn. I kind of run out of time. Sorry for being so distracted.
No, that's cool. So here's where you want to do it. You want to just say if the length of light stack is 1, right? And then just light stack, or and then that should do it. So if you run that, it doesn't break this, and then if you run it 2, you get 12, which is, wait. I think that's right. I might have miscounted.
I kind of have to
All right.
go.
Don't worry. Have a good one.
Yeah, I'll just take this that we did, and I'll just finish it off when I'm able to.
Awesome.
All right, thank you, though. Sorry for being so distracted.
Don't worry. Anyone else hanging out?
I'm still in here, but I don't really know what's going on.
Okay, that's cool. Don't worry. I would say take a look at the stack videos and a couple of the stack challenges. But if you're having trouble kind of hanging on to the stacks, go to the last module, the sorting module. We
Yeah.
use a stack in that one as well. And in the guided topic session, we talk over it a little bit. So if you see a couple of examples, it might help.
Yeah, I just got to module. I'm a little behind. I'm on module 5 actually.
Oh yeah, that's cool. So yeah, once you get to module 6, just watch the guided topic session and then maybe pop back into the recording of this one.
Okay. Thank you.
For sure.
Okay. Have a good night.
Have a good
Thank
one.
you.
All right, bye. I'll go ahead and bounce. Any other questions from anyone? All right. Well, thanks for coming. Have a good one.